Now we're going to see about orbital angular momentum. So generally what is orbital angular momentum is if the electron is a charged particle, right? If the electron revolves around the nucleus in an orbit, it possesses the orbital angular momentum. So it is designated by small l. The small l can say to be orbital angular momentum for single electron. It can be given by the expression small l equals to square root of l into l plus 1 h by 2 pi. And this small l can have the values 2l plus 1. And the small ml can said to be orbital magnetic moment for the single electron. If you see, for 1s electrons, L equals to 0. S orbital, H metal quantum number L will be 0. So that small ml will be 0. For 1p electrons, small l will be 1. So that small ml will be minus 1, 0, plus 1. For 1d electron, L equals to 2. So that small ml will be minus 2, minus 1, 0, plus 1, plus 2. That means here small ml is giving information about every single orbital. In p orbitals, there are 3 orbitals, right? So, minus 1, 0, plus 1, px, py, pz. In d orbitals, minus 2, minus 1, 0, plus 1, plus 2. dxy, dyz, dz square, dx square, y square, dzx. So, it is giving the information about every single orbital. So this is about if the single electron revolving around the nucleus, it possesses the orbital angular momentum. The small l is orbital angular momentum for single electron and small ml is orbital magnetic moment for single electron. Right? And the orbital corresponding to L plus 1, whatever the 2L plus 1, if L equals to 2, the d orbital will be having the 5 values, right? So 5 d orbitals. All these 5 d orbitals are in degenerate state because the energy of an electron depends only on the magnitude, not on the direction of angular momentum. So that these 5d orbitals or these 3 p orbitals will lies in degenerate state only, energetically equal. So when there is more than one electron in an orbital, what will happen? The energy states depends on the resultant orbital angular momentum, that will be capital L. This capital L can say to be total orbital angular momentum, or it can be called as orbital angular momentum for many electron, or it can say to be orbital angular momentum for individual electrons. This capital L can have the values. This capital L can be described with the summation of small l. Capital L equals to L1 plus L2 plus L3 and so on, ln, summation of ln. It can have the values, capital L will be 0, 1, 2, 3, 4, 5, 6. The term symbol chi can give the symbols like S, P, D, F, G, H, I. If L equals to 0, the term symbol will be S. If L equals to 1, the chi will be P. If L equals to 2, the term symbol will be D. If L equals to 3, the term symbol will be F. If L equals to 4, the term symbol will be G. So on. Okay. And the possible L values can say to be L1 plus L2, L1 plus L2 minus 1, L1 plus L2 minus 2, and so on, L1 minus L2. That is L1 plus L2 to L1 minus L2. If we have D2 configuration, P2 configuration. For P2 configuration, it is PP configuration, right? So, L1 value is 1, L2 value is 1. So that capital L values will be L1 plus L2 to L1 minus L2, right? So 1 plus 1 to 1 minus 1, that is 2, 1, 0. 1 plus 1, 2. 1 plus 1 minus 1, that is 2 minus 1, 1. And 1 minus 1, 0. So the possible L values is 2, 1, 0. Therefore, the chi, the term symbol will result for 2 it is D, for 1 it is P, for 0 it is S. D, P, S. Okay. For example, if it is having the DP configuration, DP. For D, L1 is 2. For P, L1 is 1. So the capital L values will be L1 plus L2 to L1 minus L2. So 2 plus 1 to 2 minus 1. 2 plus 1, 3. 2 plus 1 minus 1, 2. 2 minus 1, 1. Therefore, L values